Welcome to Electro Online. In the previous video, we took a look and saw what electrostatics was. Now let's take a quick look and see what electrodynamics is, just so we can compare the two. So electrodynamics is the study of charges in motion and the effects that they have when they're in motion. For example, let's say that we have a single charge that's moving at high velocity to the right, and let's make that into a vector quantity. And so two things are happening right here. There's an electric field around the charge that moves along with the charge, and then because the movement of the charge is going to be a magnetic field in a circular path around the moving charge that moves along with the moving charge. It's kind of an interesting thing. Magnetic fields cannot exist until there are moving charges. So if we also have another situation where we have a charge, let's call the charge Q, and let's say that it's oscillating up and down. The oscillation of that charge causes an E and M wave to move away perpendicular to the motion, the oscillatory motion of the charge. We have an electric field that will move in this direction and a magnetic field that will move in this direction, oscillating as it moves away from the charge at the speed of light. Again, due to the motion, the dynamics of that charge. Then here we have an example where we have a charge, and again, let's call the charge Q, and the charge is accelerating at a very high acceleration to the right. The acceleration will cause photons to be emitted from that charge. So there's energy released whenever there's an acceleration. Or for example, if a charge is moving at high speed and hits a target, so suddenly decelerating from a high speed to zero, that again will emit electromagnetic radiation in the form of photons, and that's essentially how X-rays are produced. And here we have a situation where we have an existing magnetic field. Let's label the magnetic field, and the magnetic field is pointed into the board. Now here we have a positive charge moving into the magnetic field in this direction. Using our right hand rule, we point our fingers in the direction of the motion of the charge, then we point our fingers, curl our fingers in the direction of the magnetic field, and notice that there's a force perpendicular to that motion. So you can see that the force starts like this, and that force will then cause the charge that moving through the magnetic field to change direction, kind of go into a circular path, and always the force will push perpendicular to the motion of the charge, making it go into a circular path as long as it's within that magnetic field. So you can see there's an interaction between moving charges and magnetic fields. There's the production of E and M waves because of oscillating charges, and there is the production of a magnetic field around moving charges. And as charges accelerate or decelerate at high rates of acceleration and deceleration, photons are produced sometimes at very high frequency and energy. So that's what we call electrodynamics. That's something we're going to be covering later on in the chapter, but at least now you can see why there's a difference between electrostatics and electrodynamics. And that is a good place to start in this chapter when we're going to be talking about electrostatics. So no longer electrodynamics, just a quick comparison. Now we're going to concentrate on electrostatics.
You know, your arm was constantly.
Yeah,